If you haven't already, please print out this handout so we can get started. So far we've looked at how do you count how many particles there are and how many moles are there in a sample. But when you're actually working in the lab, you're not going to measure out how many atoms or molecules there are. You can't use a scale to measure out how many moles there are. You need the mass in grams. So we need a way to convert moles and number of molecules into a mass in grams. That way it'll be more useful for us when we actually do lab work. So this brings us to the idea of molar mass. That simply means the mass of 1 mole of a substance, and it's always given in grams. The symbol for molar mass is a capital M, and the units for molar mass are grams per mole. So it's how many grams does every 1 mole of the substance weigh. If you're using the periodic table that I've provided in the course resource section, which you should have printed it out, this number up in the corner is the atomic mass, but it is also the molar mass. So we would say the molar mass of zinc is 65.41 grams per mole. This means 1 mole of zinc weighs 65.41 grams. And just remember, 1 mole is 6.02 times 10 to the 23 particles. Oftentimes in the lab, we are not looking for measuring out just a specific element, but rather compounds. So for example, calcium phosphate. If you're going to measure out a certain number of moles of calcium phosphate, you need to figure out how many grams that is in order to use the electronic balance. So in order to calculate the molar mass of calcium phosphate, that's the notation I'm going to use, I simply have to add up how many calcium atoms are there, how many phosphorus atoms are there, and how many oxygen atoms are there in 1 formula unit of calcium phosphate. So I can see there's 3 calcium atoms. This 2 outside the brackets means there's 2 of everything inside the brackets, so there's 2 phosphorus atoms, and there's 2 times 4, there are 8 atoms of oxygen in 1 formula unit. So to find the molar mass of the whole compound, I need to add 3 of the molar mass of calcium, 2 of phosphorus, and 8 of oxygen. So I simply have to look up the molar mass of calcium, phosphorus, oxygen, plug them into my equation here, and then solve for the molar mass of calcium phosphate. So I found the molar mass of calcium, phosphorus, and oxygen. I simply have to plug those in and do the calculation. Hopefully you can do this. It's 310.18 grams per mole. So if I wanted 1 mole of calcium phosphate, I would have to measure out 310.18 grams of the substance. But let's take a look down here for some conventions. First, I'm going to look at notation. So the first 3 are just review from the last lesson. Number of particles is a capital N, number of moles is a lowercase n, and Avogadro's number, N with a subscript of A. Now the 2 other ones, we're talking about mass and molar mass. So mass in grams is a lowercase m, and we already saw the molar mass in grams per mole is a capital M. So I want to show you 2 equations. The first one you've seen from last lesson was number of moles equals number of particles divided by Avogadro's number, and we could fill in our triangle to make our algebra easier for rearranging. The next one is number of moles again, but this time it's the mass divided by the molar mass. So again, we can fill in another triangle And to use it, just remember, if you want to calculate number of moles, it's mass divided by molar mass. If you want to calculate the mass in grams, well, N and capital M are beside each other, so that means you multiply moles times molar mass. If you take a look at the reference sheet provided in the course resources section, you'll see both of these triangles put together, and in fact you'll see a third triangle put in there too, but we won't get to that until the next unit. But I'll show you a little bit of what I mean right here. We need a way of converting between mass, moles, and number of particles. So I'm going to take those two triangles from above and I'm going to put them together. I'm going to have number of moles in the middle. We saw that moles can be particles divided by Avogadro's number. We saw that moles can also be mass divided by molar mass. So this gives us a way of converting between all of these different variables. So if you know the mass in grams, you can now change it into moles, and then you can also change that into number of particles. So you can effectively determine in a certain number of grams how many particles do you have. So for example, you can change mass into moles by dividing mass by molar mass. Once you have number of moles, you can change it into number of particles by multiplying by Avogadro's number. You can also go the other way. If you know how many particles you have, you can determine the number of moles and then determine the mass using the equations given. All of those equations can be figured out using the handy-dandy triangles. And if you're struggling to know how to use these, send me an email and I can give you some more explanation. But let's flip the page. In this example, we are given the number of moles of carbon dioxide, and we're asked what mass of carbon dioxide is that. So I have to determine which formula to use. I'm going to calculate mass, so I'm going to take the moles, which I know, and multiply by the molar mass. So in order to do this calculation, we need to know the molar mass, so I did some work off to the side here. In carbon dioxide, I have 1 carbon, 2 oxygens, so I need 1 of the molar mass of carbon and 2 of the molar mass of oxygen. Plug in my numbers, calculate. The molar mass of carbon dioxide is 44.01 grams per mole. So I can plug in my numbers and get my final answer. Notice that my answer has 3 significant digits because number of moles only has 3 significant digits. Let's move on to the next question. It says how many moles of acetic acid are in a 23.6 gram sample? So this time I know the mass and I want to know the number of moles. So the formula I'm going to use is moles equals mass divided by molar mass. So again, we need the molar mass, so I had to figure it out. There's 2 carbons in acetic acid. There are 4 hydrogens and 2 oxygens. Please try this one. Make sure that you can get the same molar mass that I did. If not, you made a mistake, so try and find out where it was. So again, I can plug in my numbers and get my final answer. So the number of moles is 0.393. Okay, just a couple more examples. The first one, what is the mass of this many molecules? So remember, molecules is also known as number of particles. So we have number of particles and we're asked for mass. We don't have one equation to go from one to the other, so we're going to have to do this in 2 steps. First, we need to figure out the number of moles. We know the number of particles, so to make moles, we have to use this formula. So I can plug in the number of particles and Avogadro's number, and that turns out to be 9.42 moles. The next step is to find the mass. So once I have moles, I can calculate mass just like I did before. So I take the number of moles and multiply it by the molar mass. And I'm hoping at this point you can figure that out. Remember, this is cobalt-2 chloride, so figure out what the chemical formula of that is, and then you can calculate the molar mass. So cobalt-2 chloride, cobalt has a 2+ charge, each Cl has a 1- charge, so we need 2 of them to balance out the charges. 1 cobalt, 2 chlorines gets me a total molar mass of 129.83 grams per mole. So I just do the multiplication, and I get this as my answer, 1.22 times 10 to the 3 grams. And feel free to change that into kilograms. It's often easier to think of it that way. So this is 1.22 kilograms. For our very last example, same idea except we're going the other way. This time it's asking how many molecules of iodine are contained in 0.274 grams. So this time we have the mass and we need to determine the number of molecules. So you should probably try to pause the video right now and then check your work after. So here's my worked out answer. Make sure you got the same thing. If you didn't, that means you did something wrong. Maybe it was in here for the molar mass. Did you calculate that correctly? Remember, iodine is one of those 7 diatomic elements. So it actually exists as an I2 molecule. So maybe that's where you went wrong, but if you got it, congratulations.